Hello, my name is Elena Pourmal. You probably see my name on mailing list, and sometimes I reply H5 1 year later. They call my name and like, oh my gosh, it was 1 year ago, so I'm trying to respond. So I will be talking about HDF5 roadmap for 2019 and 20 and beyond. And really, when I was preparing for the talk, I thought, oh my gosh, it's not roadmap, it's a roadmap filled with challenges and how we'll be addressing them. So I will start with how do I move?
Space bar, no? No, you
probably. Oh, I probably, yeah. Interesting.
Yeah, because you lost the focus. Yeah. So now if you lose space bar. Okay.
Oh, because the mouse was not there. Okay. Yeah. So before I start talking about HDF software, I will talk about HDF5 open source project and where we're taking our project, and then about challenges we have with software. I will talk about major capabilities and talk about upcoming releases, so you know what we're coming with and when. And touch base on new features in design. I was also planning to do 2 demos, but one demo, it didn't work yesterday night. So today we will have 1 demo, but tomorrow we have roundtable, and demos do not take much time. So maybe if I run out of time today, I can do it tomorrow. I hope they will be interested, because those demos will show how we solve the problems and new things that we're doing. So let me talk first about HDF5 as open source project. As you can understand, open source projects is not just a software. It is a community that supports and works with software, and project is not sustainable without community support and involvement. And what we have here, that HDF5 project, we should admit, lacks community contributions, and there are many reasons why. First of all, software is pretty complex and not well documented. So for any new developer who wants to start with contributing, it really, where do I start? Do I need code? Read the code, it's 5,000 lines of code, even more, and if you read tests, it's another 1,000,000 lines of code. So it's a pretty huge package. Even it's well organized, still for new developers, very hard to get in. Our users complain about obscure location of source code repository, issues, database, and documentation. We use, historically, Mike mentioned, software is used in mission-critical projects. And we were kind of reluctant. In 20 years, we went from what was the first source control, RC, it was called. You know what I'm talking about. Then it was but it was subversion. Then we went to use Git in incarnation of Bitbucket, because we use license tools very heavily for handling our project and so on. So we still didn't make this, last leap to go to GitHub. We're thinking about it, but we're not there yet. And there are many reasons why. But we have open mind. At some point, I think we'll end up at GitHub, but this process is slow. Right now, as a part of this, we have pretty cumbersome process of submitting pages, because you just cannot do pull requests. You send us a page, and we try to work with external developers, but both parties become very impatient, because contributing party thinks page is great, and internal party thinks, oh my gosh, we need to rewrite it. And sometimes collaboration goes really well, and sometimes it comes to a roadblock and contribution is not accepted. And one of the factors that contributions are not accepted, that it really pages the problem. It doesn't go and solves problem in the right way. It goes back to documentation, to architectural documentation. There is also lack of coding and development process standards, and we already started our internal religious wars about coding standards. A lot of fun, but believe me, we'll be there. And also minimum time available to HDF5, to HDF group developers to work with contributors. We're really working on the projects and spent like 40 hours working with someone on the page, sometimes simply a challenge, and we're trying to solve this problem too. And the last but not the least, it's conflict between community interest and the HDF group paid projects. Our customers, like, for example, DOE, they do not care about UTF encoding. And I'm looking at Tobias, whom I promised that UTF will be with default encoding in 112. And unfortunately, this didn't happen because when we started doing this, we discovered that we have to change so many things in the library that it will not be acceptable to our projects, our paid projects. We're still going there, we're working with them, but we cannot do it quickly. So there is always a conflict between community interests and our customers. So how we want to solve this project? First of all, really we're concentrating on addressing HDF5 developers documentation. We're planning to publish our internal standards. This is one of the things I kind of pushing this year. And we want to grow a team of external developers. We tried different ways. We gave access to Bitbucket. People were very excited. And then within 6 months, because we were dragging feet on the initial workshops and people were not available, people disappeared. So we couldn't get anyone now to, so we just picked 1, 2, 3, 4 developers and we're working with them individually so they know our development processes, our practices, and they start contributing to the code. And of course, outreach is very important. It's workshops like this, users group like we have with C++, technical webinars, and a blog that Mike mentioned already. So going further, I mentioned that we open Jira access. If you're interested, you can register at our website get your login and password, and you will be able to see Jira issues. You will be able to browse issues, vote for issues. Interesting enough, we have a lot of people with access, and still I don't see many contributions in terms of, yes, it's important for me, a vote. So I'm not sure if we still have this disconnect or people just, who cares? We'll see, but now it is there. And we have ability to submit and watch issue via Atlassian Service Desk. Atlassian is really very nice tool. And we give access to Bitbucket. If you have your account set with us, you can request and we'll give you access. And as Mike mentioned, please, if you want to participate in our blogs and webinars, we want to give you a platform. So, for example, we can have a webinar and broadcast it to the whole world. You just come as a presenter and we have your presentation. We'll be working with you. One of the ways to connect with building community, it is a connection with HDF5 ecosystem community, and we have on our web pages a software ecosystem page where you can go and see HDF software that uses purely HDF5, and you can ask us, please put my software on your list, and we try to make it easy to find. On GitHub we connect, and it's now 1,553 projects that use HDF5, also Python and HDF4. Unfortunately, it's interesting that many of those projects are dormant. They're good projects. They started live in 2008, and last contribution was in 2009, for example. But some projects are really active, and usually it's language wrappers or high-level APIs, converters, for example, for root or pandas to Postgres, they use HDF5 files, visualization and browsing tools, especially in Python, packages to work with specific type of data, for example, time series. And what is really amazing that a focus of those community projects are on ease of access to data stored of HDF5 in HDF5 and productivity. So as I said, let us know about your project. We'll add to our community portal. It will be more visible and we will know who you are, what you use. And please contact us if you have any questions. We're really looking for collaborating with community. We can write proposals, papers, participate in conference and so on. So this is my opportunity to appeal to you and work together. So just 2 examples of our collaboration. H5Pi collaboration. Unfortunately, we have minimum interaction and contributions. We worked at the very beginning with Andrew Collette very intensely when he was writing his book. And but after then, we kind of connection loss. So I'm very happy that this workshop gives me opportunity to meet H5Pi developers and see challenges that community faces. So I know, and we can build some relationships. So because it's embarrassing to answer 1 year later to, yeah, Pourmal, what you're thinking? Like, I'm not thinking anything. So our members of our group are working on code contribution for new chunk query functions, and I'm wondering, Thomas, have you heard about those or no? Okay, good. So those APIs are really cool because they provide location links and filter information for chunks, giving you capability to read data from HDF5 file by parsing HDF5 library. So we use it for some projects. Right now, I'm trying to my best to monitor and answer questions to H5Pi forum, but it's GitHub and it's kind of slow communication. And we try to use H5Pi everywhere in our tutorials when we make presentations because it's easy way to introduce HDF5 and teach new users about HDF5. And really speaking, no one is programming in C anymore. So our plans are work with H5 community at least on continuous integration and kind of synchronize our releases and engage H5Pi representatives, especially when you find the problem, how we work on it. And I saw you have a topic on your workshop for this. So another good example of it's HDFQL. It's a pretty recent project, and this is a language or APIs, I would say, that resemble SQL. It's very mature, it's very good quality code, it's supported on many platforms, and what amazed us, developers came to us and say how we can collaborate. So we presented at ISC 19 in Frankfurt in Germany, and we scheduled the presentation. Mike mentioned a technical seminar, and the author is writing a new blog is coming, and we are looking at proposals together. This year, I know there were several participants in this workshop that are coming from HPC community. Our BAF session was accepted for supercomputing. So if you are there, please let me know. We'll love to have people presenting and participating in discussion and BAF. So this is another opportunity. So now let me go to our challenges. As you understand, maintenance of core HDF5 library and tools, which is now more than 20 years old, is a challenge. And people complain about, you guys have too many warnings. Yes, compilers became much better. They became much, and we're trying to make our software better. So when you see warnings, believe me, we're working on reducing the number of warnings, but this is where really community can easily contribute to help us to improve our code. So if you are interested in seeing, and if you are interested in supporting particular compiler or a system, please, we will be happy to work with you and accept your contributions. Modularity for easy maintenance and external contributions. HDF5 library, while it's modular, it still needs some improvements, and we fortunately have some projects that now help us to do this. With the new challenges of accessing new storages, and improving I/O, we have to do architectural changes, and we are working now on creating architectural and maintenance documentation. Backward and forward compatibility. It is very important to many of our users, and this is present another challenge. We always tell our people that, our users, that HDF5, whatever version you take, will always read files created 20 years ago. And if you take your application, you always will be able to compile and build it with a new library. So it is both compatibility, backward forward compatibility. We are looking for file format and API. We are trying to make transition from release to release easy. We always break API compatibility, and the community screams at us, and we really became better because you scream at us and you ask us to fix it. So please do it, continue doing it, because sometimes we're like, oops, things happen, we forgot, even we're trying to put it in our processes. But the biggest thing we're dealing now is performance. I will show you on the next slide what happened with the library over 20 years. And we're now working on establishing performance regression testing. And another focus will be enhancing sequential performance in hyperslab selection code and supporting many objects, many thousand of objects. So what happened in the library? On the left slide, you see one of the software packages, CGNS, for computational fluid dynamics. And over the years, for the last 20 years, performance was pretty stable. So if you have regular application, you even will not notice any changes when you work with our software. Unfortunately, on the right, and this is the cause why MATLAB still didn't release SWMR. So it's not their fault, it's our fault. Because what they discovered with the internal mechanism of storing data, they use a lot of small HDF5 objects. And over the years, performance decreased like almost 3 times, going from 160, which was in 2000, probably 2003 or 2004, going to 1.5 recent release. It's really, really, really bad. And we were very embarrassed. Why? As you see, from release to release, it's really small gain, because library becomes more complex, more features are added. And when we release 1.10 with VDS, with the SWMR, it was 3 times worse. So now we're looking very carefully. And unfortunately, it's not one change that caused that slowness. It's small changes built over the years and new features that contributed. It's a clear picture. You have to measure performance all the time. You have to watch what you're doing. On the other hand, there are success stories. Those 2 graphs represent CGNS application before and after tuning. And those graphs, I will not go in detail into this, but you see the upper line, and it's logarithmic scale. It essentially, when you come to more than 1,000 processes, you cannot do anything. It's not scaling. And we were able to improve performance by adding new features to HDF5 library, by fixing it, fixing applications. So it was work on both sides. So we get to the graphs. When you see green line on the right slide, it is file per process, and it really scales well. Blue line, it's initial performance, and gray line, it's our improvement that matches very well file per process, but we are writing to 1 file. So improvements are possible, but we need to know about what your problems are. So how you can help us? Contact HDF Group as soon as possible. Measure your performance of your application. Try our releases. We are giving you snapshots and the pre-releases. Submit application kernel to our performance regression test suite. Those performance testing are submitted to public CDAR, so you will be able to see that performance. And contact us, our help desk or priority support for people, for organizations who have enterprise support customers. We're trying to address the problems as quickly as we can. Sometimes it's challenging, and we're now working on one of the problems that I hope we close to solution, but it may take time to solve the problem. That's why as soon as you know, please let us know. So reiterate what Mike said about our HDF5 development directions. We, in general, extending the current way of performing I/O. As you remember, we have usually our standard model is 1 process writing, reading to or from HDF5 file sequential, or multi-processes writing, reading shared file using MPI in parallel. So we're extending those capabilities to use to improve I/O, and we extending them with a new architectural layer that we introduced called virtual object layer, more on next slides. And we extended existing mechanism that we had in HDF5 library called virtual file drivers, and both mechanisms shown to be very, very powerful. That's why Mike told you there's no HDF5 anymore. We still can improve. Until now, we still were able to improve and extend HDF5 to accommodate new demand for new storage and for new speeds on I/O. And those 2 mechanisms allow us to access data on non-POSIX systems, because HDF5 was designed in POSIX system in mind. It's linear byte array, and you write to that byte array. So we're looking now in accessing data in cloud, in object store, and other types of memory like burst buffers and deep memory hierarchies that we see now in exascale systems. So now I will talk about major capabilities, and I will give overview. It's not a tutorial, I don't have enough time, I just want to attract your attention so you know directions in which we are going. And for parallel, for people who are working with parallel applications, there were problems reported with the scalability of file open and close. And in recent releases, in the latest releases, those issues were addressed. So if you still have them, please let us know. We resolved the issue of collective metadata I/O when multiple processes were reading from the same place on parallel file system, slowing down application. Internal HDF5 library does its work and goes away from collective and using one process to read data and then broadcasting, which improved performance in multiple times. And we added writing compressed data in parallel. We had capability to read it. Now you can write it and you can use your own filter, like dynamically load filter that we use in sequential library. Now you can use with a parallel library. Watch for a webinar announcement later this fall, because we will be having series, once again, because of projects that now pay for this, we can have webinars and training coming on new features for parallel and sequential libraries, so stay tuned. Sequential, this is a long list and I will not go because many of you are familiar with this. What I want to acknowledge here, those features were really driven and funded by light source community. DAISY, Diamond Light Source, ESRF, Soleil all contributed to those features. And we created dynamically load compression filters. And there was a question about more filters. We'll talk about it at roundtable. We created direct access to chunk data to speed up I/O. And actually, this is interesting because this is an example that we solved the major problem, but we didn't address real problem in the library. And problem is in selection mechanism. So now we're addressing it. But at least now I would call it very good workaround for quick I/O on chunk data set. We added access to data stored in multiple files and dataset called virtual dataset or VDS, and access to HDF file under construction. We first started the project, SWMR project, doing project for hedge fund, but it was never finished. And this community allowed us to deliver, which still we called first prototype, but first of all, it's working. Maybe not well, we'll talk about deficiencies later, but it made us to think how we can find another solution. And that solution is coming, and I hope you will have a demo that addresses many limitations of current implementation. Now, with the features released in 1.10, you can reuse free space in the file. Before it was possible only while file was open, while application was running. Now we can reuse free space between new open and closed cycle. Unfortunately, free space cannot be deleted. You have to repack, but at least if you are accessing file many times, you can make sure that free space is not wasted. We introduced very powerful notion of page delocation and page buffering. And first it was introduced for better I/O because you do I/O on the pages and page size is tunable. But we found that concept can be used for, say, SWMR implementation, new SWMR implementation. And this is what allowed us to quickly build new prototype that overcomes many limitations. And we have control over HDF5 file version. So if you want your application to create files that can be read by particular version of the library, you can do it now. Where you find all this information? We have under our documentation, if you go to HDF5 Application Developers Guide, release specific information, and you will find all kind of documentation for specific release. Now I will talk a little bit about the features that we introduced. How many people in the audience do not know what virtual data set is? Okay, so then this is probably appropriate slide. There was, so we were asked, listen, we're gathering data, we cannot write a lot of data. What we can do, we have several channels that can write data. And for example, on this slide, I'm creating data set A, just vector of 6 elements, B and C. And how I present this data is two-dimensional matrix and one row which is like 4 by 6, and one row is missing, so it should be field values. And we came up with and this two-dimensional matrix should be seen by HDF5 applications through regular HDF5 APIs. So just H5D read, H5D write will be able to get data from source data sets sitting somewhere in the file system and present data to the user this way. Then came much more complex use cases from different detectors. And on the left, you see that data is collected into 5 data sets that have different shapes. Those data sets are unlimited, so time is our unlimited dimension. And at each particular time step, that data from source data sets is mapped to bigger plane, and there can be gaps in the plane. And you see, for example, planes from data set A are mapped to the upper left corner of the big data set. Then they become more complex situations where we collect data in files that have kind of printf capability, F1. I can just calculate and print the name of the file. And those are not unlimited dimensions, but I want to present to the user, this is as a combination of those fixed size arrays, and each array, small cube, collects, in this case, 5 planes. And next 5 planes go to another data set and so on. Then it becomes an even more complex situation where you have planes interleaved and so on. Those are major 4 cases that now addressed, and the question is for people who use it now, because I know some detectors use it, what are limitations? And we know now that in the first place it was designed, once again, its first implementation, it was not performing well. And some performance improvements may come from our better selection algorithms, caching open source files. And recently we were asked, can you have mapping not going like in this direction, but like same direction, to first row to the right and then second row to the left of the elements. So there may be more complex mapping than just mapping of hyperslab in the same ordering. We are interested to know what kind of new use cases you have and what kind of performance problems you're getting. So please let us know. It will help us to prioritize and see where we can improve. Mike mentioned single writer, multiple reader. It was introduced in 1.10, and that, so what that feature does, you have a file, and you have one process that writes to the file, and right now it just adds new data to existing data set in the file. And then multiple reader may come in, open the file, and start reading data, and there is no inter-process communications necessary to get data from the file. I will not talk about challenges, why it is a challenging problem for HDF5, but the idea is that on the file, in the file system, HDF5 file may not be in consistent state. Applications see consistent state because there is a writer has metadata cache, and through metadata cache file, state is always consistent. But reader may not get this consistent data in the file, and if you do such access without using SWMR mode, you may crash your readers and you may corrupt your file. So there is a way to do it without SWMR, but you better use SWMR. But limitations are that implementation is based on POSIX semantics. It requires some ordering ordering of I/O operations and atomicity of I/O operations, which only GPFS system provides, and this is very expensive. Other systems do not have this. We made it to work on all systems except NSF, not NSF, NFS. And as I said, it works for raw data only. File structure cannot change. New data may not be visible for some time, and sometimes can be pretty long, which is frustration to our users. And to make it visible, writer has to use flush command, which is expensive, so it slows even more. It does work with parallel applications, introduced file locking, and order of writer and reader is critical. And I believe it's not the full list of limitations. So we are working on the new implementation that drops POSIX semantics, and we can now support NFS. It allows modification of a file structure where we can add group links, dataset, and attributes. And it also will support variable length data types. But what is more important, that it guarantees maximum time from when write availability to from write and when readers see the data. And since it's done as a virtual, as a file driver, it is separate from the whole library. It's much easier to maintain, and it will remove, when we finish it, it will remove a lot of code that is now slowing down the library. So it's one way. What time, what is the best, how much time?
You have 30 minutes.
Oh, so if you do not mind, I will try to switch gears to do demo. If my demo is still working, let's see. No, it kicked me out, but it's easy to restore.
Can I put your
not yet. I'm using secret IP address. But it didn't give me okay, so let me see if it kicked me out here too. So now we can use, I can share my screen.
Okay, I need to connect.
Oh.
Other one.
And I need to share my screen because
Yes.
And now what? We did it yesterday. It was working.
Yeah.
I don't see it here.
Who's a Mac expert?
No, let's do that one, but I will display my screen there.
Okay,
so,
yeah, that's easy.
So it
no,
will be,
worry. Okay, yeah.
so we should give me access to the screen.
I give you a screen.
And you know, that is usually not wrong. Believe me, I practiced it several times. I really like it, but I hope you like it too.
Okay, so I give you the screen.
Yeah.
Start sharing. What do I have to do?
This guy here.
That guy. I just switch it off.
Yeah.
Okay.
I think.
Stop. No one. Okay.
Sharing.
Now you share your screen.
Or maybe you do this here.
It's a little bit slow.
Let's try this here.
Should I
this thing here.
Oh, this thing, yeah.
Yeah. Change presenter to
Oh, okay. Yes, to Elena.
Elena. Yeah.
Yeah.
Oh, yeah. You've got to click the S up there.
I didn't see that one. Yeah.
Oh, okay.
Yeah.
I guess that's
Now I can share my screen.
Okay. No, it's here. Don't worry.
See my screen?
Yes, there it is. There you are. There you're on. You're live.
Oh my gosh. Okay. So I logged in to one of our Linux servers, and I'm doing it on the same machine, but it doesn't matter. If the shared file system, it will work, but demo is not set up. So I have two directories, and I created compiled the program called CADL, which stands for Create and Delete. And this demo will show that program will, in this window, I will start it, and it will create a HDF5 file. It will start creating groups, and in each group, it will be 2 data sets. And then program, as soon as it creates that system, it deletes the first one and creates another one. So at every particular time, there will be 2 groups and 2 data sets under each group. Another program, I will be using our tool, H5LS, to show that I can, it's my reader, and it will be reading the data, and you will see how quickly data will come. So it addresses, this new implementation addresses 2 issues. It is availability of data right away and ability to modify the structure of the file, metadata of HDF5 file. You do not need to stop readers, stop writer, get out, create groups, start swimming mode again. It's really very convenient. And this model, as we always try with all our new features, requires minimum modifications to user interface. So I have my, just in case, very exciting. So here first I will type it. So this is it's just an alias to the H5LS that is installed on the system. And I will specify that I will be using a virtual file driver called SWMR, single writer, multiple readers. And I will use polling because a writer should check periodically where data is. And I believe Mike will correct me, it is in milliseconds, right? Would they create that? I believe it's 100 milliseconds, but that doesn't matter, some number. And I will be doing R for reading file structure and -D for displaying data, and you will see data will move at 0 and 1s, and it will be moving, 1s will be moving because data set have different data. And my file will be H5. I just leave this command here, and in this I will start my writer. And you see it is reading. Now let me start, and it's hard to see, but you'll see that now group 64, 67. Now you see we have very small delay in 100 on the right side and on the left side. So one of the problems, and they were brought, and it's really a great idea of one of our developers, how you get rid of all dependencies of metadata flashes. So I will not show you how the reader will crash, so I will start reader first here. So it's just, I will do Ctrl+C, reader start, but now I just interrupt, as users like to do, with Ctrl+Z, suspend, Ctrl+C, kill. And usually you'll have...
Are you the first foreground again?
Do I have, it's still running? Okay.
Yeah.
So it is, so I will kill -9, brutal force. And what it is this one, right? I forgot, I didn't use 34. 740. Brutal force that users use on the system, right? So, and I should have, by the way, I don't know if I hope it works. So this is killed, and I have my file, and I will use 1.5 H5 dump that is installed on the system to see the content of the file. And the first thing I will do, it's small output, so I can do without. Okay. Oops. So that didn't work. So let me try it again. So, what?
One question.
Yeah, Thomas has a question.
So let me try once again. Ctrl+C. Yeah. And now if I use H5 done.
There's a question here.
Yeah.
One question. What would you do if you have a corrupt HDF5 file? I mean,
it depends how you corrupted that. Sometimes it's possible that if you corrupt, if you do not corrupt root group, it is possible maybe to see with a tool called H5 Debugger. I don't know if you ever use it. It's fun to use. You can go to each particular object header and try, and you can sometimes find your groups, data sets, and bit trees that point to chunk data and some data. But in many cases, it's really hard and data cannot be restored. The whole point of this exercise was that you never corrupt your file. And I managed to corrupt it. I don't know how, and this is, it works. But after I did just Ctrl+C, now you see I have my file.
I mean, my experience is the same. So I had a couple of problems with some software hardware thing, and basically, so what I had to do, I basically opened the file in hex editor and took the specification of HDF5 and changed the bits, and I got a file which worked at some point, but of course doesn't scale. So you don't have any HDF5 file repair program for a file system.
Right now we don't, and this approach we are taking will allow us to have recovery utilities. I believe you guys have it in works, right?
Yes, that intermediate,
It's coming, it's just right.
Oh, okay, yeah. So that intermediate file, the metadata file that it's creating while it's doing the read while writing, that goes back any number of generations if you want it to go to metadata writes, so that if the file does happen to, if something crashes in the middle, you can rebuild that metadata and recover the file. So file recovery was a side effect or a side goal of this project.
Yeah. It's been a lot of discussion also about having a journaling file system.
This is
This
journaling.
is like journaling.
This is journal. That is essentially a journal. Yeah, right. This is that journal.
So now let me show you another demo. This is to show you how you quickly can see your data and emulate some frames. So I have in this window the program that will be writing one-dimensional, no, it will be three-dimensional data set. It will be rising plane by plane, and it will showing you plane number. And another window will show the content of the plane and also the plane number, so you will see how quickly data is coming. So here's, I'm starting my writer, and now I'm frame whatever, you can see, and now it's working. And so let me, once again, this is fun. Someone horror games with what they're doing for this demo. So I will interrupt the reader.
Just a question, what is the lag between the two? There's a small lag, you see.
What?
There's a small lag between the writing and the
There is a small lag, and I believe this is you can control parameter, but with the when we have this implementation, we definitely should have demo old swimmer and new swimmer and see how quickly data appears. Because in some cases, when you do a lot of modifications to B-trees that handle chunk index, until you write the top node, you will not see any data. And this may not happen because of algorithms through metadata cache eviction and other changes in the library. So we have users complain and they have to pull, say, flush for every 100 iteration, which really slows down writer. But at least now you see data pretty quickly. So now I will go back to my presentation back. Any questions about it? So we will be looking for, when we will be looking for friendly users.
Oh. Well, we have the RFC now for super friends.
It's on, thank you.
Oh, it's okay. Oh, sorry. So for super friendly.
Yeah, this one, that's okay.
Oh, okay, it was red, yeah.
Here you can read it.
So for people who really want to get down and dirty with what we're doing, the RFC, which is a design of this, is available, and we strongly encourage anyone who's willing to plow through it to read it and give us your feedback on it. As far as a friendly user, we just started this. Well, this is a project that we're doing with this spin-off company that we're working with. And they wrote a small business innovation grant. We got $150,000 to do a prototype, which we did last year of this. And now we're working on the full implementation. We just got started on this a couple of months ago, and our project plan has us finishing middle of next year. So that's really going to be one where I'll have something that we'll be looking for. We'll probably be looking for friendly users earlier than that. So anybody who's interested, just let me know. I'll be sure to get you up.
Especially H5 people, so they can start playing at it because
Yeah. I mean, as you can see, there's already stuff that you can do. So, you know, if somebody wanted to jump in and try stuff now, we could even do that. But it's the journaling aspect of it, an awful lot of stuff. And we're going to do a lot of code refactoring in the process of doing this. This is a side goal of this is to really clean up the internals of the library on a lot of things that touch this. So, yeah.
But will this still be part of the 10 series? I mean,
Oh yes. This will be, the swimmer itself will be part of that. The company, when you do a small business thing, you have to say, okay, how are you going to make money off of this? So the company, which is this separate company, plans to build some tools that will make this easier to use, and they would probably want that.
It's probably
This will all be, this is library stuff, everything you saw today will be in source code.
It probably will not be in 110 series, but in the new, because we will
be 112.
In not 112, it will be next, which you saw my slide.
112, it's a VFD, right?
We want to remove another swimmer. Or we have made this decision, right? It can be. We'll decide how, but we do not want to confuse users with two implementations which have very different. So we'll see, but they can be available. Yeah. I will talk about it because really how we're doing things that should be easy for people to use it now with the libraries.
Okay. Just fix this one, yeah. You go do.
Oh.
Back to the presenter.
Presenter, right.
So this one, yeah.
Sure. I didn't pay attention to them. You never know.
Okay.
So you will ask what is behind the swimmer implementation, and this is a really powerful mechanism that we introduced pretty long time ago, which is called page buffering and page allocations. And idea behind the new swimmer is that, so let me go to the slide that shows you. We now have user interface that allows user to trigger that new space allocation in the file where small metadata and small raw data can be aggregated and allocated within the page, and I/O is performed on the page. And more than that, we introduced another third cache in the HDF5 library. We have metadata cache, chunk cache, and now this is a page buffer cache where we can have our pages cached, and we are not going to disk when we're modifying small data, small metadata. We're talking to cache, and then eviction algorithm writes to file and pages I-line, so I/O is much more performant, and tools like H5Py or other tools built on it, they can take advantage of it by providing this automatically, so users do not need to go through APIs to trigger this mechanism. And for Swimmer, it just uses cache. It takes snapshots of modified metadata cache, keeps on the file system, and readers read new data through those snapshots of metadata cache that is stored along with the index, how to find those changes on the file system. So this is, you now see the new architecture of the library when page buffering is involved. This is page layer. This is a cache that sits between a library layer that performs I/O and internals of the library that prepare data for I/O. Now I'm switching gears here for, so we were talking about features, sequential features that help you to improve I/O and organize data differently. So in 1.12, we're introducing new reference data type. You know that we had references from the very beginning in the library. And references, it is a data type. It's an element of, you can store reference to the objects that was stored in the same HDF5 file, or you can store the reference to the region, like shown, for example, in the table. My data set in the lower corner stores one of the element points to the row of the compound data set. We extended this notion now that references can be stored in objects and to the objects that are in another HDF5 file. So this way, you really can connect different HDF5 files pointing from one file to another file. And not only to the objects and regions, we also now have capability to point to attributes that are stored attached to the objects or attached to the objects in a different HDF5 file. So it's much more flexible mechanism with better interface, much easier to use, less cumbersome, and we hope it will perform. So this is coming in 1.12 release. Now let me talk about a little bit how we think about extended capabilities with HDF5. During 20 years, as we know, we added a lot of new features. And modifying library, we learned that this is probably not the best way to do it. So we have to be more modular, and we experimented with two notions of virtual object layer and extending virtual file drivers. And this is the way we are now going in this direction. So our users and customers, including our vendors, are really invested a lot in HDF5 and HDF5-based software. But as I mentioned, now HDF5 file format shows its limitation. It was not designed for new storage paradigms, and we were joking between ourselves, what will left from HDF5 pretty soon? And we agreed internally that it probably will be data model that is very versatile. Even APIs may not live long enough because low-level APIs really cumbersome to use. There are more APIs, and so. But data model is really very powerful, very useful. And we were thinking how current applications can take advantage of new storage paradigms, how we can connect HDF5 data to use with big data technologies like Spark and Hadoop. How we can use new storage paradigms to improve I/O performance, for example, how we can do I/O with object store and cloud. But what was the most important for us question to answer, can we extend the library to answer the questions above with minimum modifications to HDF5 applications? This is our focus, minimum disruption for a lot of software that was already created and in use now. And we said, yes, we can still extend our library architecture to use those new layers, and current layer we can extend to provide this flexibility. So now you see in new upcoming release in 1.12, there is colored shapes represent the existing components that are available to the library. Not filled, they do not exist or are in works. On the top level you see HDF5 APIs, and exactly underneath it is so-called virtual object layer that intercepts HDF5 APIs and may redirect it to wall connector that goes then to some custom implementation that talks to whatever storage is there, or it can go to, and those wall connectors, they can be stackable as shown on the left. They can be pass-through connectors, and we have a good implementation of asynchronous I/O wall connector that allows parallel applications to send requests to HDF5 library. I'm writing this data set, immediately leave and continue with computations. HDF5 library is not asynchronous, but that wall connector emulates this asynchronicity and gives application more way to return to applications. So wall connectors can go, as I said, to custom implementations, or they can go to HDF5 core library and go through virtual file layer that has those virtual file drivers. Some of them, they come with the library. Some of them, they will be written and be dynamically loaded. You can dynamically load it, and the design for SWMR VFD, it will be dynamically loaded VFD like you have with compression libraries. When library application triggers, I need this VFD, library finds it, loads it, and I.O. is performed. And you may write VFDs to different storages. We have in 1.12, we'll release virtual file driver that will talk to cloud. So in this picture, you see how those are two different ways of talking to cloud. As an example, we now have a REST wall connector that uses, and John will talk, highly scalable data server to talk to cloud. Or you can have regular HDF5 application of all their, whatever it can do, for example, that asynchronous I.O., but underneath there will be sitting S3 VFD that writes data, HDF5 data to cloud, and we will release those in 1.12 release. If you are interested in wall connectors, it is we are trying to gather community. Most of contributions come right now from ECP project. And we have several contributions already with asynchronous I.O. We're working, our group is working on creating Deus wall connector. There is a provenance connector, another connector called Redis APIs, which talks to Ceph and Redis object store, REST API. And there are some wall tests. If you are writing wall connectors, you will be able to run those wall tests. And if you are interested in how to write wall connectors, join us for the seminar. We will have it, will be announced, we'll show you how to write, and we're planning to write wishful thinking, but we're planning to write to one of the databases connectors to store. S3 VFD, as I mentioned, it will be released. Tools will work. You just need to specify how should you. I'm specifying SWMR driver. Here we're specifying read-only S3 driver. Very little changes to application. You just usually use property lists to specify the driver you want to use. S3 driver will have some credentials that you can pass, and then you set no other changes to applications is required. We're also releasing Hadoop driver, HDFS driver. Once again, there will be API, and people use it with Spark, and really powerful, it works really well. So now about roadmap, where we're coming with our releases. Because of performance problems, we're not dropping 1.8 releases we announced like a year ago. Until we fix our performance problem in 1.10 and 1.12, we're still supporting 1.8 for our customers. There will be security patches. We will be making sure we are not breaking forward backward compatibility. In 1.10 now it is in maintenance, and we will be adding, like a maintenance release, we can add some features that do not affect file format. Once again, security updates, but focus will be on performance. And we are, a year ago, we were supposed to release 1.12. We're still working on it. I'm still very hopeful when I come back from this trip, we'll have first, I called it beta, but I think it will be alpha. But we have to release by December 1.12. It's going well, and we will be releasing Deus Wall plugin. We will be testing other, and we're looking at dynamically loaded VFDs is in this feature, so you will be able to write your own virtual file driver and use it seamlessly with our HDF5 library. And what is coming next? Few features that I don't have time to talk, but very quickly, this is a feature that allows you to write file on local system and write the same file, completely the same on remote file system using TCP protocol right now. It will be released pretty soon. It's a good working, well-tested prototype. Why I didn't have this demo, instructions for demo was not quite yet, so I can absorb them. So skip. We're working on query and indexing capabilities, so you will be able with HDF5 APIs to query location of particular raw data or particular attributes. And we are looking, stay tuned, there will be seminar on sparse storage. HDF5 is designed for dense storage. You can store sparse data using compression, but you will do not know where the data is. And this new feature will allow you to find sparse data quickly and store it very efficiently using native HDF5 APIs. And we are very interested in supporting provenance of HDF5 files because it's very important for many applications to have kind of undo capability. And we designed, once again, virtual file driver that will store changes between open and close cycle, which we think will be enough for our customers and applications. Just new features for parallel library. Subfiling. We are working very intensely on implementing subfiling that will allow end processes to write to end files to reduce lock and contention issues on PFS. And we will be using, we are experimenting with virtual data sets for this implementation. It is there if you want to try, but we will be looking into other two solutions to have three and pick up the best. So thank you.
Thank you. Time for just leave that there for the moment. Time for a question. Questions? Any questions? Yeah.
Maybe you're wearing this.
People on.
I just wanted to be sure if I understand well your roadmap. That means that the full SWMR will not be available even for beta testing before the 1.12 version?
Or 1.14 or HDF5 2.0. We'll see. But as Mike said, it will be ready for in the middle of the next year. But friendly prototype probably will be available early next year. So please contact us and we'll work with you. Mm-hmm.
So I just wanted to add some information to the ball, to the available balls.
Mm-hmm.
So basically, actually, we've been in the loop of some mail that has been lost, as you were saying. But it's also available library that we wrote that is allowing people to write their own ball by just implementing an abstract class. And there are also balls available for object stores like Ceph, Rados, DataClay, that is an object store of Vaccines Recruiting Center, Minioball, and OpenAI.
Yeah.
So there are also other balls available. So
and the reason I put the slide to make people aware of this, and we're looking for contributions. And essentially, if you are interested, please join our World Developers Group. Send an email to me because there are some discussions going on how to develop walls, and there will be some changes in the library that may affect walls, and people have to rewrite. But we're just learning because we have accommodated so many walls that that's the reason for the release delay, because we are fixing issues found when we were implementing other walls. Okay. Yes, thank you. Please. Uh-huh. Mm-hmm.
Yes.
Hello. My question is about the full SWMR version for prototype. So it's not about the release date of this, but when you plan to release a prototype, will it be only C++ available or also with Java API?
This will be, since it's a virtual file driver, it's underneath, we will just need to create one or two APIs to trigger just wrappers to APIs that allow you to use that SWMR. That's it. It will be easy. So it will be available from all languages.
Okay.
Mm-hmm.
I had a naive question. Is with all these files and everything, the files are still compatible between each other?
Files will be compatible. Mm-hmm.
Yeah, I would like to ask about benchmark. If it's this 1.12, is you had some benchmark, or you did it to perform it slower, or is it similar than 1.10, or it's faster? Or?
It's the same at this point. Mm-hmm.
So it's this MATLAB don't use it anymore.
No, and we're working, they're waiting for us to fix the problem. We know exactly where the problem is. Unfortunately, it's an architectural problem, and we have to rework how we use some internal structures in the library for their use case. And then they're willing to switch. But also they are looking into introducing, looking at the drivers like a SWI Hadoop driver. They're trying to give access MATLAB users to cloud and object store. So they're working very closely with us.
Okay. I think in the interest of coffee, we might just stop there and carry on asking you questions afterwards. We come back here, coffee's upstairs, we come back at 11.
Thank you.
Thank you.